Okay, hello students and welcome to our first lesson in time series analysis. So we are building on from bivariate data analysis, and we're particularly looking at the explanatory variable being time. So by the end of today's lesson, hopefully you should be able to construct time series plots. Should be able to describe time series plots by identifying features such as the trend, which is just a long-term direction, positive, negative, etc. Seasonality, is it systematic and calendar related movements, or irregular, which is not systematic, there's no pattern. And there's some short-term fluctuations, and recognise when there are outliers. Then do a least squares line again to model long-term trends in time series data using appropriate technology, so Excel, calculator and so on, and then solve practical problems that involve analysis of time series data. So data collected or recorded over time is called time series data. The type of data is useful for detecting patterns that can lead to predictions about future trends. So data, that's just repeating myself. Okay, so increasing or decreasing trends are just not always easy to notice. If we have a look here, is there a pattern? Is it going up? Is it going down, for example? Or is there just based on season? So, for example, we're hotter in summer and wetter in summer and cooler and drier in winter for Bundaberg. So that's a typical seasonal pattern. And so that's a repeated cyclic fluctuation with predictable cycles of known and fixed length. What else do we have? Daylight and so on. So our seasons are very obvious ones. That's why we call it seasonal patterns. Now, irregular patterns show variation and influenced by unpredictable events like cyclones, for example, and do not fit any patterns described previously. So if we have a look here, I just went to Google and typed in Bundaberg Regional Council population or something like that, and came up with this website, and it showed me a chart, and I just stole the data from there, but they stole it from Australian Bureau of Statistics. So anyway, that's the source. Now what are we seeing here? We can see that we've got the number of people in Bundaberg for 2018, and you can see it's certainly increased a bit since 2008. So over the last 10 years, we've increased by about 10,000. But there's been some positive growth, and there's been, well, positive is growth, that's right. But I want to particularly note that, yes, we are increasing in number, but have a look here. Back in 2008 to 2009, we grew from 1,700, and in this one, we actually had a decrease in number in 2016, and that's, remember, just by the 30th of June 2016. So obviously the cyclone in 2015 played a big part in that. So you could expect that to be an outlier. And so I'm going to play with this column today. So I have just represented this as a scatter plot. I've connected the dots just to show there's a pattern there, but I've also inserted the trend line and put the equation and the R squared value in as well. If I were to describe the graph, what can we say? That over the 10 years there has been some fluctuations, but growth is decreasing. So what are we saying? This is annual change. So it's all in positive except for this one. There in 2016 there was no growth. It pretty well stayed steady. There was 2 people less. Other than that, we've had some growth. You can see that if you've lived in Bundaberg any period of time, we've certainly been affected by weather events. But you should also note that it reflects the Queensland data as well. You could expect that this to be an outlier, and summer 2011, yeah. So, and there was another cyclone earlier. So, yeah, these there is fluctuations, but overall there is growth, but the growth is decreasing. Okay, so what I'm trying to do now is just use the Casio calculator to calculate the equation of our line here. So remember, we want to find the y-intercept, the gradient and the equation. So let's enter into our data. So I'm just, well, let's go through the mode again. So we're in mode 2, we're in stat mode, and it's the second stat mode, and we've got our X and Y. So let's just punch our data in. So 2018, 2017, 2016, 2015, 2014, 2013, 2012, 2011, 2010, 2009, and I'm going to be using just a change in number today, so I'm not going to put in any 2008 data. So now let's enter in our numbers. We've got 605, 441, -2, 65, 261, 590, 1,279, 663, 1,065, 1,736. Okay, we've put our data into our calculator, and now remember we press AC and then we can retrieve what we need. So we go Shift 1 for stat mode. Let's just see what we need here. Is there anything here that matches up with this? I can't see it at the moment. So let's just see, well, the mean of the X scores is just the mean of those. So we're going to go Shift 1, and now we'll go to our regression data, and we can find B, we can find A, and from there we can get the slope of the line with the intercept and so on. So let's go 1. So 267,221. And what was that one? That was our A. So let's see if I can type that in nicely. That's going to be a bit of a pain. Maybe I'll just write it in. No, that's going to be just a bit annoying as well. Maybe I'll just screenshot it and punch that in. And then let's retrieve our other data. Shift 1, 5. What else do we need to find? Our gradient, which is B, equals, that's a -132, so Windows Shift S. And then we can state our equation. So we just know that we're just going to say y equals, what was our A value? Oh, that's a bit annoying as well. I'm not having a win today. So 260, 267, 221, and our B value was -132.38. And there we have it. That's our calculator used to generate our equation, our gradient, and our y-intercept. Okay, now if we have an example here, we've got time series data, of course, and we just want to consider the effect that a special occasion may have, for example, on the profit of a fair. So this might have been, for example, I think our centenary was around 25 years or something, was around 2015. So a special time of the life of a school might result in more people turning up and spending money at a school fair, and we would call that an outlier. We could also call that an aberrant point. Now, so it's likely, looking at this data, that this special occasion influenced the trend on profits. Now, to predict future profits, we would want to replace that aberrant point with dummy data. Now, to do that, we're just going to take the average of the points on either side. So if we have a look here, that's 1,700. and here is 1900. So we're just taking the average of those two, dividing it by 2 to get the new value 1800, and we should see that we'll put a dummy data in on the line there. And so what we have here is just, we're going to call it smoothing soon, but we're just replacing that special occasion or that aberrant point with dummy data to help with predicting future trends. Finally, are you able to construct time series plots? Identify things such as trend, seasonality, and irregular fluctuations, as well as recognize when there are outliers. Are you able to do that least squared lines to model long-term trends and solve problems with this? When you're good with that, please work on exercise 2.1 with the questions below.